Hello, Dr. Ron England, and these little mesmerizing squares that you see here are actually part 3 of the animation series that I have developed. And as you can see, as they move around, when they collide with each other, they turn red. And they also do some pretty other neat things. If I click on them, they'll change direction, so I can have them go other ways. So they got some really interesting properties to them. And we're going to talk about how we make all this stuff actually work. Okay, so again, we're going to move to the code. And first, what we really want to think about when we develop code like this that has an animation, and of course this was built from multiple other lectures, but each of these individual rectangles here is an actual object with its own properties that are important properties. And what we'll do is we're going to go over here, and even though JavaScript really doesn't make the object-oriented programming aspects you might get from other languages that tremendously easy to do, it's still quite capable of doing a lot of amazing things. So let's first look at the properties you might get with one of these rectangles. So I'm going to look at the one here called yellow rectangle, and you see that it has an X and a Y. It has an X step and a Y step. Okay, an X step and a Y step is how much does it move every time or click. Okay, it has a width and a height. It has a movement. It has an actual defined movement. In this case, the yellow rectangle, if you notice, it moves in the X direction only. A border width, a border color, a fill color, and a current color, because I can change the color of it, but I always want it to be able to go back to its default color, which is its fill color. I have one here that I call pink rectangle, except that I made it blue. I could just as easily turn the fill color into pink by changing this to pink. I just was playing around with the different colors to see what looked good, and I could then run it with the pink. I just didn't like the pink's contrast with the red. Okay, so and then of course I want to make them move around in different random patterns, so I want to click them a little bit to kind of get a different pattern here. Now, what I do with these is I have 3 of them that I've defined, a yellow, a green, and a pink, and I actually put them into an array called rectangles. So I have an array, it's a global array of the rectangles. And this is kind of a technique that you might have. If there's something on the screen, it should be defined as an object. It should have different properties that go with it. And the scope should be the scope of whatever you're using it in. Now, of course, this is a very simple screen, so global scope to this array is actually quite reasonable. Now, the whole thing is actually run off of a timer. Timer is right set up here, and we've talked about that before. Window.setInterval call animation, and call animation is the function that gets the whole thing up and running. So call animation actually what it does, and I'm not going to cover this because we've done it in other videos, it requests an animation frame with the function animate, and it passes the animate function the array of rectangles, the canvas, and the context. That's what you want to be able to draw on, and this context is what you draw with. And the rectangles are actually what's going to get drawn. Okay, we're not going to go into the mouse click yet, but let's look at this animate function here. Now, in the case of the animate function, what I do is I clear the canvas, and then I go through the entire array of rectangles, and I animate a single rectangle at a time. So I call each of them to animate one at a time. And I pass it the single rectangle because it's a for next loop. Remember that the rectangles are an array. In this case, the array is passed over here as R. And they each have an array index, and I actually have to pass over the entire array to animate single rectangle because I have to detect collisions. So when I go into this animate single rectangle, I now look at this movement. Remember that the movement, you could define that it had movement in X, Y, or X and Y. Okay? Well, the way I actually do that is determine whether it's going to be moving in both of those or one of those is I look at the index of X within the movement. And if there is no X within movement, I'm not going to move it in the X. Same thing with Y. Now, if there's an X and a Y within movement, it's going to actually move in both X and Y. I have a left and a right bound for the X, and I have a left and a right bound for the Y. And because of that, I can then, what I do is if it goes out of bounds within those bounds, I just set the X step equal to the negative of the X step and the Y step equal to the negative of the Y step. It basically changes the direction of it. Okay, and then I increment the Y step and the X step. So each one is able to move in those different ways that you want it to move. Now, I need to check for collisions. And then before, when I was doing this in a video, I only had to check for one collision, but now I've got to check for a collision of that rectangle with all the other rectangles. So what I do, and I make this relatively simple, is I come down here, I've created this any collision, and what I do is I say, okay, I've got the rectangle I'm checking, and I got the array of other rectangles, and I just make a for next loop where I check that collision against each other one, okay, and if it has collided with another rectangle, it returns a true. If you also notice, it checks to see if it's collided with itself, but it has the ability to check to make sure that it isn't itself. Okay, so in other words, if you're checking it against itself, it's not going to return a true. It's going to return a false. And the collision is just like we had before with the points in rectangle. Okay, the other element that I added to this was this mouse click. Now I am using jQuery, so I don't have to actually capture the mouse clicks, defining a listener, because jQuery does that for you. So what I do is I check my canvas and I do a click. Now this is kind of important because the canvas isn't necessarily the X and Y coordinates. The page X and the page Y is the coordinates within the page, and you have to actually subtract out the offset coordinates of X and Y to be able to have the actual coordinates within the canvas. This is important. It's the coordinates on the canvas that each of these rectangles has. If I want to click and change the direction, I have to actually click on the rectangle. Otherwise, I'm going to be clicking somewhere in space and hoping that I hit the rectangle. So I have these offsets. And the offset is simply looking at the offset of the left offset and the top offset of the canvas. This selector in jQuery is going to return the canvas, and I look at the canvas offset, and I just subtract the offset X from the page coordinates of the mouse and the offset Y of the page coordinates of Y. Pretty straightforward stuff. Okay, now I do call this function called mouse clicked down, and so I'm going to actually jump down here to mouse clicked. And what am I going to do here? Well, one of the things I actually do on mouse clicked, if you look at the bottom here, if I click on a rectangle, I get this. I either get a set of coordinates, okay, or I'm going to get, okay, a clicked rectangle, okay, if I hit a rectangle. Now, how is that working? Well, that part there, the mouse position, is simply looking at the MX and the MY. Those are the X and Y, mouse X, mouse Y that are passed over, okay. But what I have to do here is I again have to loop through all the rectangles, and I have to see if the point that I clicked, MX and MY, is in the rectangle. Now, as you recall, if you've looked at my previous videos, I've created this point as in rectangles, and I can pass it an X and a Y in a rectangle, and I can get back that whether it has actually in there. And all I do, if it is, that click is within the rectangle, the bounds of the rectangle, I set the step of the rectangle equal to times equal -1. So basically I reverse the direction of both the X step and the Y step. Well, the reason you don't see the one working in this like yellow one going in the Y axis is because if you look back at the actual definition of the yellow rectangle, the Y step is 0. It only moves in the X direction. So multiplying the 0 times -1 has no effect. So as you can see here, it's so as you can see here, I've got this really straightforward way of putting it all together. And it really, remember, code complexity. This is relatively complex code because it does some fairly complex things. But the code complexity isn't really determined by the length of the code. It's determined by the actual complexity of the code itself. So then you got to get past that fear of having a lot of code and really getting down to the nuts and bolts of what the code does. That is the breaking it up into functions, and breaking it up into logical functions does make it easy. The other thing that I do is when I'm working with code, especially in JS Fiddle, I make 5 or 6 changes and then try running it. And I make 5 or 6 changes and try running it, because if I make an error, I know that it's in the last 5 or 6 that I did. It's not easy to debug in JS Fiddle. So this code will be available to you, and hopefully this is useful. And you can use this to create the wonderful animations and games of your own that you're going to create. I will be creating some animated games for you to play with, and you will have access to the code for them. Thank you very much. Goodbye. Good programming.